people in.
Yes, please.
Just a moment. Okay, it's done. You take a bit of time. Seconds. Done.
Ja eks ta sada eurot kindlasti. Ma olen praegu katsetusteks valmis.
Good afternoon. Good afternoon from Brussels, everyone. Hope you're all doing well. We are about to start. I see a lot of people connecting. Welcome to all of you. Please make sure you mute your microphone to avoid any noise, please. Voila, then I think we should absolutely start and kick off our work. And again, I would like to ask everyone to put his mic on mute, please, so we can really start. Are we ready? Then let's go. Then good afternoon again from Brussels. Welcome to another edition of our European Lighting Forum. The European Lighting Forum are webinars organized by Lighting Europe, the trade association representing the lighting manufacturing industry. And they are our way to open the discussion with any stakeholder interested in lighting on key topics for the lighting industry. It's now 3 years, so we are organizing these webinars, and we organize discussions on several topics. If you want to know more about our past edition, we have recorded our past webinars, so you can see them on YouTube, on our page, Lighting Europe page, and on our website, lightingeurope.org. So today's topic is an environmental one. So the topic today is the assessment of the environmental footprint of light sources. Lighting Europe, we are really proud. Today it's an important day. We just published a technical memorandum on specific rules for life cycle assessment of light sources, and a press release goes with it. So to give you at least the basics of what is in the technical memorandum, and today's forum is dedicated to this technical memorandum. Then let's start and have a look. Let's have a look at our business code of conduct. Of course, we need to always respect a number of rules. We are a trade association. We may need to make sure there are no discussions or sensitive nor competitive parameters. So please make sure you respect our rules when you post on our chat. And then we have some specific rules for today's webinar. Webcams and microphones should be turned off, exception, of course, for the speakers. Your comments and questions are more than welcome by the chat box. Please make sure you indicate to whom your question is addressed, and make sure you connect today with a clear name and surname. So if that's not the case, please disconnect and reconnect with a clear name. If your name is completely unclear, we will have to disconnect you. The webinar is recorded, so it's now been recorded. Make sure that you realize that your image will be used. So this video will be published on YouTube. So you're connecting to this webinar, you accept that your image will be used. No AI tool is allowed. And you will receive the link to the recording and to the slides possibly today or tomorrow or Monday. Your feedback is also more than welcome. You will have a chance to click on a link via the chat, and in the email you will receive. Now I would like to give the floor to my colleague, Teresa Selvaggio, Director of Public Affairs of Lighting Europe. She will introduce you to the topics of today's webinar. Teresa, the floor is yours.
Thank you, Elena. Welcome everybody also from my side. I'm happy to see that again we have a high number of participants. This shows big interest on the topic. And also it could be that some or maybe many of you were with us already some months ago when we presented in a similar event a similar technical memorandum. In that case, it was about product-specific rules for control gears for light sources. I think it shows already the level of engagement and somehow of leadership of Lighting Europe on these topics. But I will take a few seconds to explain you why we are doing that. And if you move to the next slide, Elena, please, we can give an overview of how we are trying to drive harmonization on LCA rules for the lighting sector. While we're doing that, we recognize overall an increasing interest from the market. The next speaker will speak more in details on this. So on the one hand, a big need of reliable sustainability information, but at the same time, this does not correspond to the right harmonization of rules. On the contrary, high fragmentation. And that's why already some years ago, Lighting Europe decided to become active and engage to drive harmonization. So what we did until now, very quickly, our experts, first of all, have contributed actively to the revision of the PSR 0014 for luminaires. This is the document from the program operator PEP Eco Passport. It relates to luminaires, of course. And it is now, let's say, evolving also in particular at international standardization level. Then we realized, our members realized that we needed to also look at the components of luminaires, and therefore a work had started and from our end have been accomplished, and now again it's moving towards standardization. And I'm referring to the technical memorandum for control gears that was presented, as I was saying, some months ago, and that, by the way, is freely available through our website. And today we have the pleasure instead to present the technical memorandum for light sources. Again, in order to achieve the maximum level of harmonization, we are engaging at international global level through the Global Lighting Association on these topics. We support the mutual recognition agreements among program operators, but especially our members are actively engaged in the standardization process of these rules at international level. And with this, without any further ado, I have the pleasure to introduce to you our speaker of today, but also of last time. Of course, he's a leader in our association and a great expert on these topics. I'm referring to Dee Dentenier. He's Director of Standards and Regulation in Signify. He's actively engaged in our own working group Sustainability, where he's the chair of the task force product-specific rules. He's also our representative at the technical committee of the PEP Association, and he also is an active member in Eco Platform. So with this, I have the pleasure to pass indeed the floor to Dee to really kick off the more detailed and technical presentation.
Thank you, Teresa, for these kind introductory words and this excellent introduction to the position of Lighting Europe with respect to the LCAs and EPDs. There's one thing where I would like to object. You put far too much focus and spotlight on myself. This is, as everything in Lighting Europe, a collaborative effort. All the members of Lighting Europe have contributed to the content that I wanted to present. I'm not going to single out all the members that have contributed. I still would like to single out one. That's Henrike Streppel of LEDvance. She's been acting as technical editor in the process by which we came to the rules that I will present. And everybody who knows this field knows that the technical editor is the person doing the real work. So credits go definitely to Henrike for her hard work. And I would like to emphasize that as a start. And then get going on the content.
Objection accepted.
Thank you, Teresa. It would be terrible to start off with a fight on these topics, but I'm glad you're okay with this. Yeah, let me take my own summary of what Teresa said and then continue on what we'll be focusing on today. So the world is experiencing quite some environmental crises. I'm not going to deep dive that. And responsible manufacturers will want to report about the environmental footprint of their products. Customers will want to know about these footprint of the products. Legislation is also encouraging to report about this environmental footprint. EPDs have been selected as the primary vehicle to report numerically about these environmental footprints. And that's why the big interest about all this is. It's supported by a wide body of scientific research. So it is also a credible approach towards reporting such environmental footprints. What we do then today is talk about harmonization of approaches towards EPDs. If we look at the general standards, we'll come to that. There's pretty much room to fill in details in whatever way you want. And that will confuse markets, we're sure about, and harmonization there is needed. And the specific rules that we talk about today, the specific rules for the light sources are one way to harmonize the approaches, and there exist next to other documents that we've been working on in Lighting Europe. That is the specific rules for the light, for the luminaires, and the specific rules for the control gears. I think the specific rules we will be discussing today are important in two ways. One is they're important in itself, as it will enable manufacturers to report in a harmonized way about the environmental footprint of light sources for general lighting. But secondly, it will drive also, we trust, the availability of EPDs for light sources that can then in turn be used in the environmental product declarations for luminaires. It will provide a source of primary data to be used in the EPDs for luminaires, and that is really needed because the EPDs, they stand or fall with the quality of the data you have, and the more primary data you have, the better the tool becomes. Okay, having said that as a sort of generic introduction, let me then move to the agenda of today. We talk about the background, product-specific rules for lighting products. Then we talk about the specific rules for the life cycle assessment of light sources for general lighting. So we zoom in on the specific element that we're adding today. And then we talk about the relevance to industry and applicants. Okay, in terms of background, let me start off here very generally. And we've provided, as Lighting Europe, already lots of content and information about LCAs, EPDs, and product-specific rules. So I've taken the opportunity to select a few of the slides and the information elements. As Teresa pointed out, you can find all of that and more on the website of Lighting Europe, and you're strongly encouraged to have a look there if you have not already done so. Then, just to set the scene and the abbreviations, the life cycle assessment, it's a methodology for assessing environmental impacts associated with all the stages of the life cycle of a product. And a typical life cycle of a manufactured product includes raw material extraction and processing, transportation, manufacturing, distribution, product use, and end-of-life treatment. And then having looked at all these life cycle stages of the product, you can quantify the impact on the environment for each of these stages. And that's what we typically do in the EPD. The EPD then is a document, a report, a standardized and verified document that summarizes the environmental performance of a product over its life cycle. And they are based on this LCA methodology, but they're further standardized according to specific standards called product category rules, usually covering broad classes of product and product-specific rules, zooming in on specific product types such as luminaires, control gears, and light sources in the case of lighting. But it can be batteries, it can be cables and wires, it can be all sorts, it can be concrete, it can be all sorts of things. I trust this is bread and butter for most of you by now. We see this is a growing trend in the lighting industry. What I've done is I've taken a from Eco Platform. That's a platform where program operators gather to harmonize practices. And you can see there the statistics, the growth in the number of registered EPDs. And you see a quite strong growth of this, reflecting the big demand for such environmental declarations. There are a few drivers for that. It's in customer demand. They're the most universally recognized and increasingly required by the market. There's many building programs that require EPDs to be provided. There's many municipalities that want to improve their environmental footprint in their operations and in their sourcing, and they would require typically EPDs, and there are many examples of that. It's also driven by regulation in Europe. There's the construction product regulation, which already mandates some of the information that you would typically have on the environmental footprint. It's expectation that this regulation will be broadened towards other product classes beyond construction product, and it's already mentioned in the ESPR. We also believe that in terms of numerically quantifying environmental footprints, the EPDs are a scientifically sound approach. They're based on open standards, they're leveraging experiences from other industries, they're covering all life cycle stages, and they're verified by experts. And all of these contributes then to a trustworthy source of information. And by working on this together, we also ensure that the quality of the EPDs improves as we go along, as more primary data comes available from our suppliers and data and material providers. In this way, companies also use the technology, the approach to improve products and services, and use LCAs and EPDs to make sustainable decisions. As Teresa has already told, and I'll also not stop emphasizing this, Lighting Europe has been quick to realize the importance of EPDs and provided several LCA and EPD trainings to its members. They can be consulted for a much more background. But we've also realized something else, that harmonization is needed. And we started off with this by looking at environmental product declarations for luminaires and the specific rules that tell you how to do this. There we had, and that's already talking a few years ago, an identified concern that there was a lack of harmonization of LCA EPD practice in the lighting industry. And to understand this, but also to motivate and enable the industry to adopt more harmonized approaches, we collaborated with the PEP Eco Passport and supported the review of the PEP PSR 0014. And we've communicated extensively about this. The result was the PEP PSR 0014 edition 2, product specific rules for luminaires. And it was published in 2023. And it's been quite a success in the market. Today we see that over 300 PEPs for luminaires have been published by the PEP Eco Passport organization, and that has been done by over 40 manufacturers. So quite some adoption already of this in the market. We've been promoting this extensively by providing information about the PSRs and motivating the need for harmonization, zooming in on the rules offered by PSR 014. We see that an approach in collaboration with a program operator was a good and solid and also successful start, but that in the end, more harmonization and internationalization is needed. And therefore, we kicked off or enabled IEC standardization running on top of the PSR 014 methodology and published this PEP PSR as an IEC publicly available specification. And there's a committee drafting IEC 63627, which will then elevate this document with the input from other stakeholders to an IEC standard, as we trust. It's definitely in the making. During this work, we identified additional needs for rules, requirements, and guidelines. That is for the core luminaire components, the light source and the control gear for the light source. Light sources, lamps, LED modules, and control gear. Well, we talked extensively about that in our previous light forum, but that's the unit inserted between the power supply and the light source, and that serves to supply the light source with its rated voltage and rated current. Generically, these are relevant to create the EPDs for the light sources and the control gears and to harmonize the approaches for these EPDs. So they're relevant in itself to harmonize the approaches, but are also relevant to drive the availability of EPDs for light sources and control gears to support the creation of EPDs for luminaires. I cannot sufficiently stress that the quality of the EPDs depends on the quality of the data that you put in, especially for an assembly type of operation that we typically run in the lighting industry. And to make these specific rules available for the components, we trust that many EPDs of light sources and control gears will become available, and then they become primary data sources for the creation for the luminaire EPDs. The technical memorandum, specific rules for the life cycle assessment of control gears for light sources, has now been completed, and that is what we are now today celebrating. It's good to realize that this technical memorandum, as well as the technical memorandum covering the specific rules for the control gears, are developed independently of any core product category rules, the generic rules covering broad product classes. And we believe that they can be used together with different core PCRs, the EN 15804, the EN 50693, the IEC 63, etc., so that we have made these rules available for a broad set of program operators harmonizing approaches for lighting products. We believe that all of these should end up in IEC standardization. I told you we have started this process for the luminaires, but we're now also elaborating the first steps for the light sources and the control gears. And we believe that already now, these specific rules can be adopted by all interested program operators. And it's important to realize that as soon as the IEC standards will be completed, that will be the big changeover in the market, and any sensible, I would say, operator would adopt these. However, already now we would like the process to drive the process of harmonization, and we would like to encourage currently all program operators, even though there is no commonly, broadly accepted standard available to already take a look at these products, at the technical memoranda we produce and the rules we have offered. So they have the first steps of harmonization already happening before that the formal standard emerges. Okay, so this is it for a general approach, expanding on the material and the things we have discussed previously. Let me now take the time to dive into the specific rules for the life cycle assessment of light sources and provide you with a glimpse of the definitions we have there and the technical rules. Before doing so, I would like to do a quick reminder. Again, how do these rules fit in with a general approach for EPDs? Well, basically, we always say we have a broad set of ISO standards that govern LCAs. And basically, we try to model the whole set of available standards as a sort of pyramid. And at the bottom of these are the general rules and requirements for doing LCAs. And that's the ISO 14014 and the ISO 14044. And the general rules for EPD creation and rules for program operators that typically govern the product of the process of EPD creation, the ISO 14025. Then on top of this has been built the product category rules for construction products. It dates from the 2010, so to speak. And they tell you how to do EPDs for construction products. Again, as a next level in this pyramid, we see the IEC 63366 related to the EN 5693, which have product category rules for electronic devices. And they provide details on how to approach EPDs for electronic products. These then will in turn be complemented by rules for specific electronic products, and the luminaires, the control gear, the light sources are a case in point. When explaining about this pyramid, I sometimes get the objection, hey, this pyramid is not really a pyramid because it looks like the way you present it, the IEC 63366 is a constraining of the EN 15804, whereas in fact it's a complementary, an additional product category rules for electronic products next to the construction product. And that objection is absolutely valid. I still provide this as a pyramid, because if you look at it in the temporal sequence, you see that the IEC norm and also the EN 5693 norm was developed considerably later than the EN 15804. And although it's not formally a further restriction and specialization of the EN 15804, it definitely builds on top of the EN 15804 and the IEC 63366, in my view at least, can be best understood if you also understand the concept of the EN 15804. And then, for instance, the impact categories are specified more precisely in EN 15804. IEC 63366 allows you to deviate from them, but it also allows you to build on top of the EN 15804 constructions. And therefore, I think that a view of this as a pyramid is proper and adds to the understanding. But if you want to put the IEC 63366 next to the EN 15804, please be my guest. I think that is formally correct, but then maybe misses some of the points I would like to emphasize. Whatever the case here, the top of the pyramid, the specific rules, is what concerns us here today. Specific rules to develop EPDs for light sources. And that will exist next to the specific rules for luminaires that's already being standardized in IEC 63627. Okay, when we again still take one little step back from the specific rules and say, hey, what did we try to design? What thoughts were guiding the design of these specific rules? I have tried to single out a few, and I think that will give a good insight on how these specific rules were constructed. First, they must be usable in conjunction with the most relevant core PCRs. So our main how you say that, affiliation is presumably with the electronics core product category rules, the IEC 63366, but the EN 15804 is so relevant in the market that we would definitely also like to be the rules, like the rules to be used together with the EN 15804. So that's why we emphasize that they should be usable together in conjunction with the most relevant core PCRs. We think that's important. That also explains some of the language that we have, because the product-specific rules usually is built on top of a very well-defined norm on the EN 6366 or the PEP EcoPassport PCR or what have you. We do, and then also references into these core PCRs. We want it to be generically useful, so we don't reference any specific PCR, core PCR, but therefore what we're making is not a product-specific rules, and that's why we call it a technical memorandum containing specific rules. So that explains our language, but also explains an important part of our approach. It must meet the requirements on PSR as set in these core PSRs. And I think there the clearest expression of that is in IEC 63366. It explains what we do in the product-specific rules. We have a focus on scope and definitions, making sure that the system boundaries for the EPDs are identical. We focus on functional unit, quantifying the performance of the product and making numbers more comparable. We need to define the same declared unit, and we have similar use scenarios. So IEC 603 clearly points out these are the important things in the specific rules, and that's why we also in our technical memoranda have focused on these. We also aim for consistency with the approach in PSR 0014, having various specific rules to do APDs for lighting products. You benefit by some harmony in terms of how the rules are constructed and some consistency in approaches. So this is clear. There's also consistency with the eco-design and energy labeling. It's about definitions, reporting some key parameters of the products. We want this to be in line with the core regulatory constructs that we have here in Europe. And we also mandate consistency of the technical data required to prepare the EPD and the technical data sheet. So there is a tendency to when you start developing EPDs, you have to describe what kind of information is to be included there. And we want the information in the EPD to be consistent with the information in the technical data, so that you, because sometimes different approaches would be possible. Okay, the light source is the topic of today. I don't think I have to explain a lot about this. They typically come as lamps and as LED modules. The surfaces or objects emitting light, typically an electric light source, commonly called light source, defined as primary light source with a means for connecting to the power supply, and usually designed to be incorporated into a luminaire. An electric light source can be an electric lamp or LED module. That's some clarifying language adopted from the IEV. But in all reasonable expectations, you will know what we are talking about. Typically LED lamps, and LED modules. In scope of the technical memoranda are white light sources fulfilling some chromaticity conditions. There's a restriction on the luminous flux and per the square millimeter. And you will recognize that A and B are definitely aligned with the Ecodesign for Light Sources, the EU 29/2020. And the chromaticity constraints, that's also in line with the IEC 624.177, where the term white light source comes from. It's not always the fortunate word white light source, because here it means that because this definition also includes color tunable light sources, but this is anyway the way the things are called in the IEC. Therefore, I prefer some other more generic term, light source. When we look at these light sources, some concepts become absolutely relevant when we later dive into the calculations in the EPD. We have the useful luminous flux, and that would be determined at the on-mode power P on, again a quantity that we have from the single lighting regulation. And the on-mode power P on is the electric power consumption of a light source in full load when all lighting control parts and non-lighting parts are disconnected. And so it's the energy consumption at full load used for generating the light. And the full load is the condition of a light source within the declared operating conditions in which it emits the maximum undimmed luminous flux. The useful luminous flux then it depends, as we also have per single lighting regulation, on the directionality of non-directionality of the light source. And we split out the case of non-directional light sources, in which the total flux is calculated in a solid angle of 4 pi sterradians, and that's corresponding to a sphere. And then we distinguish the case for directional light sources with beam angle over 90 degrees. And for directional light sources which are more focused and have a beam angle smaller than 90 degrees. Again, all in line with what we have in the single lighting regulation. Another important topic is when we talk about environmental information, about sustainability information, is the lifetime of a light source. And there we have taken the approach to take the L70B50 as the basis for our calculations. It's again defined in accordance with the Commission Regulation 2019/2020, the single lighting regulation. And it's the time in hours between the start of the use and the moment after 50% of a population of light sources has degraded to a value below 70% of the initial flux, the L70B50. And for non-LED technology light sources, we have the B50, the moment at which 50% of the population of light sources has failed. This is all fairly common. And typically we have lifetimes, operational lifetimes. We also need lifetimes of the declared unit in years, and that is because of the specificity of EN 15804, where that is required. And here we have a simple conversion by dividing the operational number of hours by the number of hours in a year to come to the years of operation. And with lifetimes there come various specificities. What temperature is there used? Where is that measured? And we have taken the approach that the lifetime shall be given in the EPD along with the temperature of the measurements, and that the lifetime must be justified in the report. And again, that's very important. The assigned lifetime shall be consistent with the information in the technical data sheet. Okay, then we come to the core of one of the core elements of the specific rules. That's the functional unit and the declared unit. The functional unit is the quantified performance of the product. Here we have taken to provide a useful luminous flux of 1000 lumens during a reference lifetime of 35,000 hours. So again, this normalizes the environmental footprint to the provision of 1000 lumens during 35,000 hours and provides the footprints on comparable basis. The declared unit, I usually say very simply, this is the light source that we're talking about in the EPD. It's the one light source providing a useful luminous flux of the lumen package of that light source at full load during its assigned lifetime of expressed in years. And the expression in years, again, happens here because of our wish to align with the practice in EN 15804. Two concepts, and there may be heavy arguments. What is the more relevant one? I would always say it depends on context, and in fact there's an easy conversion of the environmental impact expressed as needed to provide the functional unit as the environmental impact of the declared units, because you have then to remove the normalization by 1000 lumen and the 35,000 hour, and you have to take out the lifetime and the actual lumen package of the light source. Okay, then we having set all these definitions, we come now to the use stage of the light source, which is again at the heart of the product specific rules, and provides the scenarios for the energy consumption during the use phase. And indeed, when we look at the use stage, of course, EN 15804 and IEC 63366, they provide additional elements for the use stage, the B1 to B7 for the use, maintenance, repair, replacement, restoration, and energy needs, and the water needs. We deemed that for the light sources, only the B6 is relevant. So that is the only item in the use stage, the B6, that need to be calculated for the light sources. And you will also recognize that as the most relevant environmental imprinting during the use stage. Okay, how do we then look at energy consumption? And here we definitely have something that is not common, not mentioned in the single lighting regulation. However, it's absolutely in line with the product specific rules that we developed for the luminaires. So we consider light sources, and we also consider the light management function that's implemented in the light source. And you can have light sources, and that will be still pretty much often happening, that don't have a light management function. And then you have light sources with integrated light management function. And integrated meaning here that there's some hardware integrated into the light source that manages the light over its use stage. There's various ways that this hardware can manage the light over the use stage. And there may be variation or extinction according to brightness of day. Typically, you integrate a light sensor. There may be variation or extinction according to presence or absence. You integrate a movement infrared sensor or something of that kind. You combine these two. You can have autonomous time-based dimming light sources, as we have it from the control gear specification, and there may be a connected light source. Again, connected light source is well defined in the single lighting regulation. Light source including data connections parts that are physically or functionally inseparable from the light emitting parts. The light source can have physically integrated data connection parts in a single inseparable housing, or the light source can be combined with physically separate data connection parts placed on the market together with the light source as a single product. And so the hardware really is integrated, or in some other sense inseparable from the light source and sold together as a looking at these light sources, light management functions, you can calculate the energy consumption of the light source with light managed function over its assigned lifetime. And we expressed it in kilowatt hours as the P on times the assigned lifetime times the theoretical energy saving coefficient. And again, P on, we defined that previously in this presentation as the power of the light source operated at full load and expressed in watts. And there's some stipulations here. The assumption is that the light management function does not influence the assigned lifetime. There's also another relevant stipulation, and that has to do with the relation to EPDs for luminaires. Often we say, hey, these EPDs for light sources can be used in the creation of EPDs for luminaires, and that's also an important use case. But in that, you should not use this energy consumption. When you integrate the light source, specifically a LED module, into the luminaire along with the control gear, you know more about the application and you have more specific means at your availability. The configuration, for instance, of the control gear will determine the power delivered to the light source, and the calculation will then change. So this calculation shall not be used when you create the EPD for the luminaire. Okay, then this is still dangling what we think in terms of the theoretical energy coefficient that we have mentioned there for the light source without a light management function, and that there is a theoretical energy saving coefficient of 1. So moving back, it is just the P on times the assigned lifetime that determines the energy consumption during use. However, when there is an energy management function available, the energy consumption is reduced, and this energy consumption scenario tells you how much it is reduced. And again, consistent with the PSR 0014 and in the control gears PSR, we have reductions of energy, which ranges to 25% reduction of energy for presence detection and daylight dimming, up to 50% reduction for connected light sources. And as said, in line with PSR 0014. Again, the EPD should report about the applicable light management function that has been used in the EPD. We come now to a important topic of the product-specific rules, that is homogeneous families. Seeing the great variety of light sources we have, it is at times convenient to report about multiple light sources in one EPD in order to reduce the EPD, in order to reduce the effort, and in order to make life simpler. And this is possible by means of the device of homogeneous product families. The product families have been properly defined in the specific rules for light sources, and by and large it must have the characteristics as listed here. I'm not sure that at this time of the Light Forum, it is tremendously important to go through the full list, but they must be similar enough, so to speak, that it is relevant to be able to include all the product types into one EPD. They have the same range of products, subject to the same product standards, be made of the same material types, etc., etc. It's also important that we have this for electronics. As said, we have quite a variety of products, often expressed in product families. It is nice to be able to express in one EPD the environmental footprint of all the members of this family. It's also clear that we need specific rules here for electronics. A traditional approach is to allow the inclusion of multiple products in one EPD, but then typically you would limit the environmental footprint of the product to a certain percentage, say, or plus or minus 10% of the environmental footprint. For electronic products and specific for lighting, this constraint is not necessary, because sometimes we produce products that have a range of wattages and lumen outputs, and we very well understand how this goes and how this impacts the environmental footprint, and going from what shall we say, 100, 500, 600 lumen to 1200 lumen light sources. We know very well how this scales, and so this restriction on the environmental footprint is not necessary in case of light sources. So that's why it's important. Next to having this definition of homogeneous product families, we also have the definition of the scaling of the environmental footprints, so that you can extrapolate or scale the performance of one product in the family from the environmental footprint of the base product in the family, for which we have full numbers reported. And the manufacturing stage, the scaling is split up according to the various stages of the life cycle. And for the manufacturing, we scale by the weight of the PCBs, the LEDs, the mechanical and electrical and optical components, and the packaging. So that's 3 ingredients that go in there. In the distribution, we scale by weight. For the installation, we scale by weight of the packaging. In distribution, the weight of the packaging and the product will determine how much effort it takes to distribute a product. In installation, it's typically the packaging waste that provides the impact, and therefore the scaling by the packaging weight is appropriate. Use stage, it's by power, lifetime, and energy saving coefficient. End of life, we scale by weight, again, of the electronics and the mechanics. And in the module D, and that's the impacts of the product beyond the system boundaries after the end of life treatment, we again scale by the weight of the PCBs, the mechanical, and the packaging. So this enables us to move from the footprint from one base product for which all the calculations have been done in the EPD to the footprint of another member of the product family by rescaling all the calculated impact values. Okay, so this is about technically what I wanted to say about the specific rules. Let me then again zoom out and talk about the relevance to the industry and applicants. Lighting is a relevant market with an annual turnover of around 15 billion. And so I would say to the program operators, hey, there's value and business in these specific rules. EPDs are becoming increasingly more important to the lighting industry. We've seen that, and we've seen some numbers there. Lighting component EPDs will be a strong enabler for luminaire EPDs, and harmonization will further improve the uptake of EPDs. There's a few central themes that we've seen throughout this presentation. Lighting Europe has contributed to the specific rules for the life cycle assessment of luminaire and luminaire components. We do this with the aim of harmonization. We do this definitely with a view that this should be elaborated in IEC with a view towards global acceptance and having additional views incorporated. However, while this standardization is in progress, manufacturers are strongly encouraged to consider the current rules, to already move to a harmonized approach for these lighting EPDs while the standards are being created. I would strongly then encourage the program operators to consider these rules, and also the software providers for EPDs, and the manufacturers to push their EPD and software providers to implement these rules. And the rules to drive this adoption, the rules are freely available to all LCA program operators and standard development organizations without limitation. And I think that by this means, by making it easy, by making it freely available, we will be able to develop a harmonized approach to the EPDs of lighting components, and will establish a healthy EPD ecosystem. With these words, I would like to conclude. Simon, Teresa, I don't know who will over, and I would like to hand over to you, so that maybe in questions and answers, elaborate on the material that I've presented today. Thank you very much for your attention, at least so far.
Thank you so much, Dee. And indeed, it is now time for our Q&A session. We are running a bit short on time, so I will be very brief with also this announcement. We've talked a lot about availability, and I'm sure you've all been asking yourselves, where can I get this wonderful set of rules that were so expertly presented by Dee today? And it is very easy. You just visit the Lighting Europe website, and you should be able to find these rules available for public download just on our website on the front page. So please feel free to use them, to integrate them into whatever rules that you may have, and also to please share with us all your feedback and questions that you may have. With that out of the way, let's jump into the Q&A. We already received a couple of questions, so I would be very happy to go through them. So let's start at the top. Maybe just as a quick recap explainer, would you be able to quickly explain the difference between PEP and EPD?
Yeah, a PEP is an EPD, but it's an EPD published through the program operator PEP EcoPassport. That is my short way of saying this. We see many program operators making EPDs available, and PEP is one of these program operators. They happen to have called this a PEP, but it is one of the EPDs.
Indeed, it's an acronym heavy world, so I think it's always good to just get a little bit more explanation from time to time. Another question or comment that we received, so maybe you can elaborate there a little bit. If a light management function varies or turns off the light source's luminous flux as it's considered by the energy saving coefficient, then the 1000 lumen over 35,000 hours functional unit is not fulfilled. So maybe could you explain a little bit the relationship between the impact of the light management function, how it relates to the normalization with the functional unit?
Yeah, it is constructed so that this functional unit is fulfilled. It provides the equivalent of the 1000 lumen but you can do a little bit less because the full 1000 lumen is not needed there. So that is how it is done, and that is the appropriate way of looking at that. But indeed, in some literal sense, you could interpret this as not providing the 1000 lumens.
Thank you again for that explanation. So another question that we received, do these specific rules cover acceptable background databases?
That is a very interesting topic, and the answer is no. We have not yet fully deep dived, I would say, the role of the background databases in the lighting EPDs or in the EPDs at all. We see first studies of that, for instance, for packaging, plastic resins, a variety of case studies we see appearing that have interesting results. We haven't done that for lighting, and so these specific rules do not include any stipulations to the background databases.
Thank you very much. I also see that there's a hand raised from Mark. If that relates to a question, I would really like to ask you to post that via the chat to keep it nice and orderly. And maybe in the meantime, Dee, could you explain maybe a bit how harmonized rules could contribute to making the life easier for lighting manufacturers that have, for instance, a large variety of luminaires?
Oh yeah, so when doing the EPDs, you have to develop a number of scenarios yourself if left on your own. Now you don't have to think of that. You can just follow the rules in the product-specific rules. So in that sense, there are rules for energy consumption. You can debate about this forever. We know that, and we also do that in the standards committee. And we take away this burden from the companies, and then also ensure a harmonized approach in the industry. And so it takes away effort. And there's more examples there. If you talk about packaging composition where it's not relevant, there's some scenarios for that. So it, in that sense, it makes it easier.
Thank you very much. We are running already a little bit over time, but I would like to give our audience just one more moment to ask any questions that they may have. But if there are no additional questions, then I think you've done an excellent job, Dee, because you managed to explain everything so perfectly.
Yeah, I'm still sorry that I took so much time.
No, I think it's highly appreciated.
I always get so enthusiastic when I talk about this that it's difficult for me to stop. But
no, it's very much it's an exciting topic, and we are very happy that you shared your wisdom with us today. And now it just leaves me to thank everyone for attending this European Lighting Forum today. And of course, special thanks to Dee, who's really been a pillar in Lighting Europe's work in the EPD environment. And he will be certainly missed in all our discussions around EPDs and LCAs. So please, everyone, stay tuned for more events coming up in the future. I know that we are currently discussing some very exciting things, so please keep an eye on that. If you have any further questions, if you'd like to be invited, please shoot an email to our colleague Ilana, and you will also be receiving the survey as well as a recording of this link to the recording of this webinar. And we would be very, very happy to hear some feedback for you. And with that, I thank each and all of you, and I hope you have a lovely afternoon.